Hello everybody, this is Miss Richardson, and today we're going to be discussing what exactly is a function. So I have the formal definition of a function written up here. A function is a special kind of relationship between two pairs of values, usually an x and a y. One value will be known as our input, and the other value is known as our output. Every single input must map to only one output. And when I say only one, I mean one unique output. Whatever I put in has to go exactly to something that comes out, and it has to go to the exact same value every single time. An example of a real-world function that I like to use every now and then is a vending machine, because what do we mean when we say a vending machine is functioning? We mean if I am to put something in, like for example this vending machine that I have here, if I were to enter A3, well then I would expect out of the vending machine to pop a choco bar. If I were to enter B4, well then I would expect milk to come out of this vending machine. And so we have some relationship here where I'm relating some number value or some alpha numerical value, let's say A3, that goes into my machine, my vending machine, and out of my machine I get out my choco bar. And so if every single time I put in A3, I get out a choco bar, I'm like, okay, this machine's doing what it's supposed to do. If I put in A5 and I get out a jelly bean, the machine's doing what it's supposed to do. If I put in B3 and the machine outputs water, it's doing what it's supposed to do. It's functioning properly. But what if I come back the next day and I put in A3, the same code as I see listed here, but all of a sudden it gives me out a nut cookie? Well, that's not what I want. This machine is not functioning because it's given an input, but it's not putting out the exact same output that it was putting out yesterday. And so this is not a function. That's what we mean when we say every input has to return the same output every single time. And so let's explore the domain and the range of this function, because every function has two parts. The values that we put into it, we call those values the domain of our function. And then we have the values that come out of my function. We call those the range. And so if I were to list the domain of this vending machine function that we have over here, well, I would have elements A3, I would have A4 and A5, but I'd also have B3 and B4 and B5. As for my range, what is the output I would get? Well, I would get out a choco bar or a nut cookie, sorry for the bad handwriting, or a jelly bean, or water, or milk, or last but not least, orange soda. And so if I were to draw what we call a mapping diagram, which is just when I'm drawing an arrow from every single element in the domain to its corresponding element in the range, I would take a line, for example, from A3, and I'd go to choco bar, because I know that A3 goes in and choco bar comes out. A4 goes to nut cookie, A5 goes to jelly bean, B3 goes to water, B4 goes to milk, B5 goes to orange soda. And so this machine is said to be functioning because every time I put in one of these values, the correct output comes out every single time. And like we said, it wouldn't be functioning in any other occasion. For example, if I also had A3 going to nut cookie, we can't have one input go to more than one output. That contradicts the definition of a function, yes. And so let's consider two different avenues in which we can explore the characteristics of a function. One way we can do this, so this will be an example we're going to consider, is it a function? So one way for us to do this is just using a table of values, something where most of us should be used to at this point in mathematics. I'm just going to make up some values. Let's say that I have an interesting table, I never said that this was a table representing a function. I just said it was a table representing some relationship that we want to determine whether it is a function or not. So let's say that this table puts in 0 and then it puts out the number 3. It puts in a 1 and it puts out the number 4. It puts in 2 and it puts out the number -8. It puts in 3 and it gets out the number 0. It puts in 0 again and this time it gets out the number 0. It puts in 1 again, and this time it gets out the number 0. It puts in 2 again, and this time it gets out the number 0, and same thing for 3. It also gets out the number 0. And so what are we seeing here? We're seeing some relationship that says 0 goes to 3, as 1 goes to 4, as 2 goes to -8, as 3 goes to 0. But wait, 0 doesn't only go to 3. We see that 0 also goes to 0. So if I were to imagine this as a machine, I'd put a 0 into the machine, and I would expect a 3 to come out. But then later on, I put the 0 in again, and this time I get out a 0. That machine is not functioning. It's outputting different values for the same input, which is not okay. And so this relationship that we have here, this one would not be a function. So we'll just say no. Another way that we can notate a function is just using a rule. So I'm going to write an equation. We will determine whether this is a function or not. So let's say I have the equation y equals 2 plus x. And so a good way to model this equation is, of course, again, a table of values. We know that we can pick our own values for x. Being that x is the independent variable, it stands on its own. You can choose for x to be whatever you please. Y is the dependent variable because it depends on whatever the value of x we choose to be is. That's because I plug in value of x in here and then I add 2 to it, and that will tell me what y comes out. It's entirely dependent on whatever x value that we put in. For example, when I put in x equals 0, of course, y is equal to 2 plus 0, which is really just 2. But when I put in x equals 1, y is now equal to 2 plus 1, which is 3, and so on and so on. And 2, I would get out 4, and for 3, I would get out 5, and so on and so on. This is a pattern that would continue in this way. As our x's get bigger, the y's continue to get bigger. And so we can kind of observe just from these beginning values that this is likely going to be a function. I see 0 corresponds to 2, 1 corresponds to 3, 2 corresponds to 4, 3 corresponds to 5, and there's no other possibilities that when I get back to 0 that I'm going to have any other value than 2, because we see that these values both keep increasing on and on and on and on. Yeah. And so for this one, we see it is a function. Nice. Let's look at one more. So for this one, we're going to look at a graph. I'm just going to draw a grid. I'm not going to number any values. I'm just going to draw that there. And we are going to determine, would this represent a function? And so it's interesting to kind of explore, would a blank shape represent a function? But we have to really think about what we're dealing with here. And so we have a circle. We see that for this circle, there's a bunch of points on the circle. There's points all around it that we connected to form the circle. And so if I were to imagine these points, I don't need to imagine every single point. Maybe I'll just imagine this one, for example. Whatever the x value for this point is, I see that it's lying on the y-axis, so I know its x value is going to be 0. I don't know what its y value is, but I also don't really care what its y value is. I'll just put some question mark. I can see, though, that there's somewhere else on the circle that has that exact same x value. If I go down here, we see this point here has a 0 as well as its input and a completely different y value. I know they have different y values because, well, this one's down below the x-axis and this one's above the x-axis. So we know this one would be a positive number, while this one would be a negative number, and so on. And so, again, it breaks the rule that we need. We need, in order for this to be a function, every single input to correspond to only one output. I can't have 0 outputting one number, a positive number, and then come around and have 0 output a negative number. That is not true for a function. And so we see here, this is not a function as well.